Hello, everybody. So, in today's lesson 5.3, we're going to be working on estimating quotients. And remember, quotients means answer to division problem. So, how can you estimate decimal quotients? That's our essential question. So, we're on page 217 of the fifth grade Go Math textbook. So, let's go ahead and get started with the unlock the problem. All right, so Carmen likes to ski. The ski resort where she goes to ski got 3 and 2/10 feet of snow during a 5-day period. The average daily snowfall for a given number of days is the quotient of the total amount of snow and the number of days. Estimate the average daily snowfall. All right, so the total amount of snowfall was 3 and 2/10 feet. That fell over a 5-day period. So if we divide 3 and 2/10 by 5, we'll get the average amount of the snowfall per day. Okay, so how can we do that? Well, we can estimate decimal quotients by using compatible numbers. Remember, when choosing compatible numbers, you can look at the whole number part of a decimal dividend or rename the decimal dividend as tenths or hundredths. Okay, so 3 and 2/10 divide by 5. So here's two different ways. Two students solved this problem or estimated this problem. So Carly and her friend Marco each find an estimate. Since the divisor is greater than the dividend, they both rename 3 and 2/10 as 32/10. Okay, because so we look at this and we say 3 divided by 5. Well, we know that's less than one whole, right? Because 5 times 1 is 5. So our dividend's less than the divisor. So they're saying, all right, well, I know I can't share 3 wholes with 5 groups. So let me rename those as 30/10. So now I have 32/10. All right, so 3 and 2/10 is 32/10. All right, so we're basically saying divide 32/10 by 5. Well, she said, oh, okay, well, 30/10. That's close to 32, right? And that easily divides by 5 because 30 divided by 5 is a basic math fact. So use the basic math fact to find 30/10 divided by 5. So 30/10 divided by 5 is 6/10, right? 5 times 6 is 30. And we write that as 0.6. So her estimate is 6/10 of a foot of snowfall per day. So Marco, what did he do? Well, he looked at the 32/10 and said, well, that's close to 35. And I know that 35/10 divided by 5 divides easily because that's a basic math fact. 5 times what is 35? 7. So 35 tenths divided by 5 is 7/10. Or we write 0.7. So in his case, he's saying, well, there's about 7/10 foot of snow per day. Well, so we know our estimate roughly is between 6/10 and 7/10. Now remember, these are estimates. So there's really no exact right answer. Okay, it's a reasonable answer. These are both reasonable because the numbers they're using are both really close to 32/10. Okay, and they both used 5 as the divisor. So the only difference is between 30 and 35. So you could say, well, which one's closer to the original number of 32/10? So which estimate do you think is closer to the exact quotient? Well, probably the one that has the closest to the original numbers. So 30/10 is only 2/10 away. 35/10 is 3/10 away. So they both are really close. So I would say Carly's. Okay, and why did I say Carly's? Well, both They both use the divisor 5. .30 is closer to 32 than 35. Okay. All right, let's look at number 2. Explain how you would rename the dividend in 29 7/10 divided by 40 to choose compatible numbers and estimate the quotient. All right, so if we were just looking at this as, let's just say, since the 29 is smaller than the dividend, than the divisor 40, we can think of this as 297 tenths, right? So that's the first thing I want to do. So I'm going to rename 29 7/10 as 297 tenths. Remember, there's 10 tenths in every whole number. So 29 times 10 is 290, plus the extra 7/10, 297 tenths. All right. Then I would use find compatible numbers. That divide by 40 easily. And that's close to 297. So when we think about that, so 40 times 1 is 40, 40 times 2 is 80, right? But we want to get close to 297 tenths. So which multiple of 40 is closest to 297? Well, if we just look at the 4 times what? What is a multiple of 4 that's close to 29? 7, right? So 7 times 4, that would be 280. 280 tenths divided by 40 equals 7. Or we can use, or I can use the next multiple of 4, so I have 320. Divided by 40 equals 8. So we know our answer is somewhere between 7 and 8 tenths. Page 218. Estimating with 2-digit divisors. Well, a group of 31 students is going to visit the museum. The total cost for the tickets is $144.15. About how much money will each student need to pay for a ticket? Well, our total amount is $144.15. We have 31 students that are going. My question is about how much money? So when I see about in an answer, that usually means estimate, right? So let's use this. 144 and 1500s divided by 31. Let's use 30 for the divisor, right? Because 31, I really don't know my math facts by 31s. But 30, I can just look at the three tens to help. So I'd be looking for a math fact that's a multiple of 3. All right, so when I go 3, I can go 3, 6, 9, 12, 15. 15 is close to 14. So let's go 150 divide by 30. Well, we know that if the dividend ends in a 0 and the divisor ends in a 0, we can eliminate those because we're dividing by 10. We can divide both numbers by 10. All right, and 15 divided by 3 is 5. So each student would pay about $5 for a ticket. So that's one estimate I could use. I could also go with the number that's smaller than the actual amount, but still divide by 30, because 12 is a multiple of 3. If I eliminate that, we'd get 4. So each student would pay about $4 if I did that. So the question becomes, which estimate do you think will be a better estimate of the cost of a ticket? And explain your reasoning. All right, so let's say we estimate that we're going to have $4 a ticket, and I collect $4 from each student. Well, that $4 is going to get me to about $120, right? But it says I need $144 in the question. So maybe I want to use the larger estimate, because then I'll be sure to have enough for each ticket. So I'm going to use the $5 estimate. Because it's better to know the greater amount, in order to have enough money for each ticket. Okay, so if we estimate with $5 and we collect roughly about $5 from every student, we know that 5 times 30 is $150. So 150 is more than 144, so we would have definitely enough money if I collect $5 from each person. All right, so let's look at number 1. Use compatible numbers to estimate the quotient. Well, we're dealing with 9 here, right? So if we divide by 9, we'd be looking for multiples of 9 that are close to 28. Again, we want to try to get as close as we can to 28. Now, these are possible answers that I'm showing you. Because what if somebody rounded this to 10 and used 30? Their answer might be different than mine. It's not in this case because I'm going to use 27. Okay. 28 is close to 27. 27 divided by 9 is 3. Okay. But I could have also used 36. Which one's closer? 27. Okay, so 3 is definitely a closer estimate than 4 would be. All right, let's look at number 2. 393 and 5/10 divided by 41. Well, I don't know too many 41's math facts. So I'm going to change that to 40 because I do know my 4 math facts. And so we have 41 shared 41 groups sharing 393 and 5/10. Well, the divisor is smaller than the dividend, so I can use the whole number amount. And so I would use 400. 400 is really close to 393, and 40 or 400 is a multiple of 40. 40 times what is 400? 10. Could I use 360? I could. I could say 360 divided by 40, right? And so that would be 9. So somewhere between 9 and 10. Okay. Again, these are possible answers. It depends on what numbers you use to estimate, but they need to be reasonable. Okay. I wouldn't change this to like 800 and then divide by 40. That's not reasonable. All right. So number 3, 161 and 7/10 divided by 7. Okay. Well, I like the 7. So let's keep that. And what's a multiple of 7 that's close to 161? Well, 70. I mean, that's not really close to 160. 7 times 2 is 14, so 140. That's a little closer. So I could say 140 divided by 7. And the next one would be 210. That's really not close to 161. But I suppose it's something that's reasonable. So 140 divided by 7, I could say, is 20. Or if I did 210 divided by 7, I would come up with 30. So it's somewhere between maybe 20 and 30 for our quotient. All right, 17 and 9/10 divided by 9. Okay, well, this one, I wouldn't use anything other than 18 divided by 9. 18 is just 1/10 off of 17 and 9/10. Use the divisor that they already have. So our answer is going to be real close to 2. All right, number 5. 145 divided by 21. Well, I'd like to use 20. And then what multiple of 20 is close to 145? Well, if we change that to 140, that would be 7. That seems to be the most reasonable one. The next one I would use is maybe 160. Again, that's much further away, right? 140 is closer to 145 than 160 is, but it's not impossible to use 160 divided by 20. So our quotient would be somewhere between 7 and 8. All right, estimate the quotient. 15 and 5/10 divided by 4. Okay, this one, I would use only one possible answer. 16 is the closest to 15 and 5/10. So my answer would be about 4. It's actually going to be less than 4, but the answer is going to be about 4. The only other reasonable number would be 12. 12 divided by 4, 3. Okay, but which one would you say is closest to the actual quotient? 16 divided by 4, because 16 is closest to the actual dividend. All right, 394 and 8/10 divided by 7. Well, let's use the 7. Okay, so what's a multiple of 7 that's close to 394? Well, we can focus on just the beginning numbers up to the tens. 39 divided by 7. Which of those 7s would be closest to 39? Well, 350 would work because 35 is a multiple of 7. I could also use 42. So change that to 420. So 350 divided by 7 would be 50. Or if I changed it to 420, my answer would be 60. So it's somewhere between 50 and 60. 18, 410 and 5 times divided by 18. I'm going to use 20. And I'm going to change 410 to 400. 400 divided by 20 is 20. I'm going to stick with that. Okay. I'm not going to use 600 for sure. And I'm not going to use 200. So I'm going to stick with 400 divided by 20. And number 9. Okay, I'm going to keep the divisor 7 for my estimate. And I like 70 for that one. 70 divided by 7, 10. What could be another possibility? Well, our next 7 would be 77. So we know our answer is somewhere between 10 or 11. 32 and 4 tenths divided by 52. I'm going to change the 52 to 50. And 50 is bigger than 32. So I'm going to think of this as 324 tenths. 324 tenths. Well, 300 tenths would be close to 324 tenths. Or what's the next one? 5, 10, 15, 20, 25, 30, 35. So 350 tenths divided by 50. So our answer is either 6 tenths or 7 tenths, depending on which way you change your 32. All right, numbers 11, 134 and 42 hundredths divided by 28. Okay, well, I'm going to use 30 on this one. And a multiple of 3 that's close to 13. That would be $120, right? Or I could use $150 divided by 30. Okay, so 120 divided by 30. That's 4. So we know his answer is about $4 or $5. 150 divided by 30 is 5. Okay, number 12, 21 and 8 tenths divided by 4. Let's keep the 4. And 21 and 8 tenths, that's close to 20. Or I'd go up to the next one, which would be 24. So 5 or 6. 3 and 4 tenths divide by 5. Well, 5, the divisor, is greater than the dividend. So I'm going to think of this as 34 tenths. So I'm going to use 30 tenths divided by 5 or 35 tenths divided by 5. And 35 tenths is closer to 3 and 4 tenths. So our answer would be 6 tenths or 7 tenths. Number 14. Okay, so $759.92 divided by 42. Now let's change that to 40, okay, to start. All right, now a multiple of 40, or 4 in this case, let's just look at the 4, 8. Okay, well, let's change that to 800 then. 800 divided by 40. Well, we know that if the dividend ends in a 0 and the divisor ends in a 0, we can cross them out because we can divide by 10, divide both of them by 10. 80 divided by 4 is 20. So an estimate of about $20. Okay. And I probably wouldn't use $400. That's too far away, right? That's not reasonable. So this is probably the best estimate. Okay, I'm not going to do one that's smaller on this one. Okay. Number 15. Shane has a total of $135.22 to spend on souvenirs at the zoo. He wants to buy 9 of the same souvenir for his friends. Choose a method of estimation to find out about how much Shane can spend on each souvenir. Explain how you use the method to reach your estimation. All right, so we have $135.22 divided by 9. Okay, so what can we do? Well, he's only going to buy 9, so I probably wouldn't change the divisor. I'd keep the divisor 9. So let's look at multiples of 9. 9, 18. Definitely not 27. So 90. So it's going to be about $10. Or if I use $180, again, these are just estimates, right? It would be $20. So which one is the more reasonable amount that he could spend? Well, between 10 and 20, right? If we did change this number to 10, we could divide by 140 by 10 and get 14. That's kind of in between them. So maybe we should stick with this estimate. Okay, so let's do this. So I am going to use 10 as my divisor and 140 as my dividend. 140 divided by 10 is $14. So I can spend, so Shane can spend about $14 per friend. Okay. So let's look at why I changed it to the 10. So when I looked at this and said 9 times 10, 9 friends times $10 each, that's $90. Well, that would still leave him a lot of money to spend for each person. So I wasn't very happy with that one. And then I went, well, okay, so 9 times 20, well, that's $180. That's more than he has. So I didn't like either one of those estimates. One I thought was really too low, one's definitely too high. So I went ahead and tried, let's change this to 10 instead of 9. And what would be a multiple that could he be easily divided by 10? 140, which is close to 135. So 9 times 14, 9 times 4 is 36. 9 times 1 is 9 plus 3, 126. So that's pretty close to 135. So 9 times 14 is $126. So that's pretty close. All right. Page 220. All right, use the table to solve 16 and 17. All right, so 16, we have the greatest 7-day snowfall in 3 different states: Alaska, Wyoming, South Dakota. 186 and 9 tenths, 84 and 5 tenths, 112 and 7 tenths over a 7-day period. Okay, and so we have to do, how does the estimate of the average daily snowfall for Wyoming's greatest 7-day snowfall compared to the estimate of the average daily snowfall for South Dakota's greatest 7-day snowfall? Well, there's a couple ways we could look at this. Well, why don't we first just look at the two of them and just subtract? Okay, we know the divisor is going to be 7. Okay, so we know we're going to be dividing an amount by 7. I can divide both of these by 7 and subtract. Okay, that's one way I'm going to do it. Or I can estimate to start by rounding to the nearest 1. Well, 112 and 7/10, that's close to 113. And 84 and 5/10, that's close to 85. Well, let's subtract those then. 113 take away 85. 3 take away 5, we can't do that, so let's regroup. 13 take away 5 is 8. I can't take 8 from 0, so let's regroup. 10 take away 8 is 2. So 28 divided by 7, that would give me 4 inches more per day. All right. Or we can divide both of these by 7. 84 divided by 7. And what multiple is close to 112? Well, let's see. 7, 14. So 140. So 7 times 12 is 84. And 140 divided by 7 is 20. So in this case, it would be 20 take away 12, which is 8 inches. So I would say that the difference is between 4 and 8. So, all right, how does the estimate of the daily snowfall for Wyoming's greatest 7-day snowfall compare to the estimate of the average daily snowfall for South Dakota's greatest 7-day snowfall? All right, so Wyoming's would be 84 divided by 7 equals 12. South Dakota would be 140 divided by 7, which equals 20. So 20 minus 12, 8 inches more on average. All right, number 17. The greatest monthly snowfall total in Alaska is 297 and 9/10 inches. This happened in February of 1953. Compare the daily average snowfall for February 1953 with the average daily snowfall for Alaska's greatest 7-day snowfall. Use estimation. All right, so in 1 month, 297.9 inches. And it says February. So let's assume we had 28 days. Could have been 29 days. Maybe we should use 29 days. Yeah, we can use 29 days. Okay. We know it's 28 or 29. 29 gives us a nicer multiple to use. So 290 divided by 29. We know that that's just 10. All right, so 10 inches per day in February compared to 186.9 divided by 7. So over its 7-day period. So what is a multiple of 7? That's close to 186.9. Well, again, we could use 140 divided by 7, or we can use 210 divided by 7. So it's going to be 20 or 30, right? So if we take 30, because that's closer to 186, so I'm going to take 30 minus 10. I'm going to say it's about 20 inches more. 20 inches more. So the average daily amount for 7 days was about 30 inches. So that looks like 50, I know. So 30 minus 10 equals 20 inches. Okay, because for the month of February it was about 10 inches. So, all right, number 18. During a 3-hour storm, it snowed 2.5 inches. Jacob said it snowed an average of about 8 inches per hour. And it can't be 8 inches. 8 times 3 would be 24 inches. There's only 2.5 inches. So it's not even 1 inch per hour. So what's reason? Yeah, he might have called this 25 tenths divided by 3 would give him about, if you rounded that would be 24 divided by, if you use a multiple of 3, it would be 24 divided by 3. That would give you 8. But it wouldn't have been 8 inches. It would have been 8 tenths inches per hour. He may have used 25 tenths to estimate 24 divided by 3, which equals 8. But it should be 8 tenths, not 8 whole inches. All right, and 19. Juliet will cut a piece of string that is 45 1/10 feet long into 7 smaller pieces. Each of the 7 pieces will be the same length. Write a division sentence using compatible numbers to estimate the quotient. All right, so our divisor is 7. She's going to have 7 smaller pieces. So what's a multiple of 7 that's close to 45? Well, we could have 42 divided by 7 equals 6 feet, or 49 divided by 7, 7 feet. So we know it's between 6 and 7 feet. I would say this is the more reasonable estimate. She's going to have about 6 feet per piece because 42 is closer to 45. Okay, so that's it for lesson 5.3. In our next lesson, we're going to be working with division by whole numbers, division of decimals by whole numbers. So until then, I will see you soon.